So today we are going to take a look at some of the many uses that electromagnetism has in our daily lives, really, and how we can take this concept of electromagnetism and apply it into a lot of the day-to-day things that we take for granted. Uh, Today we're going to look at how a lot of these devices will use the interaction between electromagnets and permanent magnets to make them do what we want them to. And a few of the devices that we're going to touch on today are called galvanometers, which that word might sound pretty foreign to you, but maybe you've heard of a voltmeter or an ammeter or just the speedometer on your car. Okay, these are all types of devices that use this concept. Electric motors, I think you're all familiar with that term, but maybe we didn't even understand the depth of where electric motors play a part in our lives. And of course, loudspeakers, which is just another name for speakers. But and I know how much you guys love your earbuds. A galvanometer has got a magnetic needle that's going to deflect when an electromagnet gives off a magnetic field by it. All right, depending on the strength of the electromagnet, it's going to make that magnetic needle deflect greater or less. Now, there's a nice little diagram here. Don't get psyched out by the Russian language there. That's not. I'm not worried about that, knowing that. But the diagram is really good. As you see, there's got a north pole and a south pole, kind of surrounded a coil of wire. And when that electric current goes through there, okay, it's going to create electromagnetism, and it's either going to attract to the north pole or be repelled by the north pole, or vice versa with the south pole. And that's going to cause that needle to move. And that's how a voltmeter and an ammeter work in terms of how we can measure the amount of current or how measure the amount of potential difference in a circuit. And the same way that in your car in terms of your speedometer. Electric motors, we're all familiar with the name, but maybe we don't, again, understand the amazing diversity that we take this concept to in making our everyday devices. The shaft of a motor is something that's going to spin. That's how a motor works. Now we translate that into all kinds of different things. The reason it spins, though, is because there's an attraction and a repulsion between opposite and like poles of an electromagnet and permanent magnets. Obviously, the opposite poles will attract and the like poles are going to repel. All right. And if you look at the diagram, especially the one on the right there, it's kind of a cross section. It's as if the shaft of the motor is kind of coming out towards you. All right. And you see a north pole. And in this old diagram, they've got a P for the south pole, but and the S stands for the shaft, is just a bar that's going to come out. And the idea is to get that to spin, to get that to turn. And when we run an electric current through that, we make a electromagnet in the center part. That's going to get repelled by the north pole and attracted by the south pole and vice versa, and it's going to turn. Well, that's great. It would turn one half turn and stop. But we play a little trick on the electric motor, in that every half turn, then we change the direction of the current. And by changing the direction of the current, we reverse the poles of the magnet, of the electromagnet. And so then they're going to be by like poles again, and we want to get to the opposite poles, and they're going to make another half turn. And every half turn, we keep changing the direction of the current and changing then the poles, which is going to cause it to keep going. A loudspeaker uses attractions and repulsions between electromagnets and at least one pole of a permanent magnet to cause vibrations, to cause that interaction to be attracted and repelled and make some sort of film move and vibrate, which is going to produce our sound. And so as the electrical impulses travel from your stereo or your phone or whatever the device is that you're using, it sends a little electrical signals into a coil of wire, which creates electromagnetism. All right. Well, when there's a permanent magnet nearby there, it's going to attract and repel to that permanent magnet, and it's going to cause movement, and that's going to produce our sound. Now we're going to take a look at some more specific examples and hopefully bring it home a little bit for you.
First, we're going to show a little example of a electromagnetic device that is called a galvanometer. And we're going to look at what's called a multimeter. In this case, it's a combination voltmeter and ammeter. Right now, it's set up in the voltage setting, and so it's going to be measuring volts. And so if I look at my circuit here, I've got a circuit lined up. If I flip my switch on, light comes on, and I see that it's in place. Now, a voltmeter has to be wired in what's called parallel. We talked about parallel last unit. So now I can check the voltage of this circuit by touching the lead here, and you'll see the needle on the voltmeter will jump based on the voltage that the batteries are producing. If I flip my switch, light comes on, I can test my voltage again. Now it jumps maybe, but not quite as far as some of the energy is being used by the light. If I slide over next circuit, I've got a ammeter set up. Again, it's set on the ammeter setting, or the amps. And so when I turn my, when I press my switch, I see the needle move. Again, it's going to be dependent on how much current is flowing through there. Will produce a different amount of electromagnetism, causing the permanent magnet to be repelled or attracted relatively to the amount of magnetism that is being produced by the electromagnet. Next up on our electromagnetic devices is an electric motor. This is an electric motor, an example of one here. And as we alluded to, that the idea of an electric motor is that when the electricity flows through there, the shaft of that motor is going to spin. So when I touch this terminal, I cause that shaft to spin because of the attraction between the opposite poles and the repulsion between the like poles inside the battery, or inside the motor. If I look over this next circuit, I also have an electric motor. This one's hooked up to a little propeller. And if I turn that on, make that spin, and make a nice little fan. Inside the electric motor, you'll see coils of wire there. And that's where, when the electricity goes through, they form electromagnetism. And they're going to attract to the opposite poles and repel to the like poles of permanent magnets that are also housed inside, around the casing there. And so, because of that, we can make that shaft spin and do all kinds of amazingly important things for us. Let's take a look at some examples.
The last device that we're going to look at is a loudspeaker, or just a speaker for that matter. Might be from your stereo, might be for your television, might be just from your earbuds. But they all work with the same concept, and that is that there's an interaction between electromagnetism and a permanent magnet. In this case, what happens is when an electric current from, maybe your phone, for instance, sends a signal to through the wires to your speakers, it's going to cause little pulses of electromagnetism, which in and of themselves won't do anything, but when they're near a permanent magnet, that's going to cause interactions, attractions, and repulsions, which cause a vibration. And that vibration then, of course, is how sound waves occur, as we spoke to earlier this year. I'm going to show you just a model of a real simple speaker, one that is homemade. I just got a plastic cup, and to that plastic cup I wrapped a coil of wire. And so when my phone, and it's hooked up to a headphone jack, when my phone sends a signal to the coil, it's going to cause a little electromagnetism. Now at first you won't hear anything, and even when you do hear it, it'll be pretty quiet, so you might need to turn up your volume. But then I'll move a magnet close by, and then the volume, the sound should start forming. So I'll press play, Right now, nothing's really happening. When I move the magnet close, now you should be able to hear some sound. Now, it's not a great speaker. I'm not saying turn your AirPods in for this, but it certainly, hopefully, shows us the concept of how it all works. That's it for today. Do your quick quiz, and we'll see you tomorrow.